So I'm Georg. I'm from the Vienna office. So in Vienna, we have our computer vision team. I was invited to talk a bit about our sparse mapping technology and also telling you folks something about the meshing that we are running on the device. So I hope that after the session, you will be experts in doing that and how you can get the most out of our mapping algorithm. Everything starts for us for mapping based on our SIGSTOF system. And what you can see here is our normal SIGSTOF tracking system, which we also call VIO. It's a visual inertial odometry system. In action. It detects on the fly some points, it hangs onto them, and based on the points that we are detecting, we can determine the pose of the device itself. That works pretty robust, usually, so we invested a lot of time to make sure that it runs efficiently and also that it can track already pretty accurate. However, it usually adds a relative drift to your system. That means the longer your trajectory is, the longer your trajectory is, the more offset you will see at the end. We detect several points in the scene, we are snapping onto them, and this helps us tracking the thing. However, after a while, if we're lost, there's no way how you can recover. Even if you cover the cameras and you walk somewhere and you uncover the cameras, in the end you would have a different pose than before because the system wasn't able to track. So what we add on top of that with mapping is more memory to the system. SIGSTOF is only having a very short period, a very short-term memory where you have only a few points in it. We can then just attach the mapping algorithm under the hood on top of it. What it does is it's storing the points that come in from the system. It detects some more points on its own. It's serializing them. It's also performing loop closing, drift correction, and also map.io. So everything it needs that you can save the scene and that you also can load it and that you can relocalize in the space. So something that spatial anchoring is actually doing. So it saves the map and then you come back, reload it in the background, and then everything pops up where it was before. One of the most important things I just want to highlight here is that there is a difference in our system between meshing and mapping. Often these two things are getting confused. And also when you create a custom location, we usually create a mesh and a map in the background. We only use the mesh that you see here on the right side for letting the user edit content against it in Lens Studio. Meshing itself is a little bit more heavy on the computer vision side than the pure sparse mapping algorithm that you see here on the left. And since we are on a very thermal and power constrained device, we made them that they work independent of each other. So if you talk about sparse mapping, it's all about poses, pose information, correct poses, including the drift of the VO system, so we also can correct it under the hood, and also for persistent augmentations. And what you can see here on the left side is the actual map we created for the SBS connected council dome that we had there. First of all, you can see the domes, it's like a half sphere, and we detected many points. So we're picking up features in that environment. You could also see the trajectory that we were just walking in there while we were mapping it. So for that experience, we just wanted to make sure that it's on point whenever people go in there and we can snap on it immediately. And for that, you just need to walk around and make sure that you covered all the viewpoints. Because also, back then, we didn't know if there are going to be any crazy computer vision engineers in it that cover the cameras and try to break the system. So this is what we're usually doing if you gave us a device in our hands. So we tried to break it. And by that, it would just not have happened, right? You can also see very nice here the centerpiece. So down here, this is the circle that was also included in our map. And as soon as you walk into that, you see these kind of whiskers. So this is when we are snapping onto the points. And then based on these points we are snapping on, we can infer the pose where we are. Meshing on the other side is just a really dense reconstruction of the environment. So mainly for visualization in Lens Studio, physics, occlusions, but it doesn't give you any persistence and you also don't need it for persistence. By that we can make the mapping algorithm very, very lightweight on the device itself. One very important aspect of mapping and relocalizations and also spatial anchors and also drift correction is the concept of loop closing. And this is a very important concept to understand to also make sure that you can get the best out of that system. So what the system does in the hood is it detects a scene and it does that by finding matches between two different images. So if you look at an image, here's just a very small example, it's going to extract corner points, it's going to describe these corner points, and then it tries to find it in another image. And it means, so we don't store images inside of our algorithm for privacy reasons, so we have that in an abstract form, so we only have the descriptors in there. And what that means is the system needs some texture to hang on to. So if we would put our algorithm, that's true for the VAO algorithm and also for the mapping algorithm, in a completely white room Where there are no corners, there is nothing, then it will just immediately break the system because there are no points, nothing that the system can snap onto. Same for very, very dark rooms. Like we need light, so this is a computer vision algorithm. Vision, we need light, that anything works. So what it does now is it finds matches between these two things. So these are these green lines here. And once we have these matches and we know where the points are in the 3D space, you can just, by using normal geometry, you can infer the relative pose. Also inside of our system, there's some rigidity assumptions. That means we assume that things are not going to change their relative poses too much. So how can I imagine? So if you would have a balloon, right, and you have some texture on it, and you inflate that, that could actually break our system because all the relative poses are just changing on the fly, right? Usually this is not happening. These are very special cases that we have there. So in normal situations, when you are at home, where you have a little bit pictures on the wall, where you have clutter on your desk, where you have a carpet that's not fully white, usually we can really nice map everything and detect it. And mapping works normally instant. For spatial anchors, we can map in seconds and give you the confidence that we can save that already in the background. Another feature that we added, which is also super useful for our spatial anchoring, is multi-map tracking and incremental mapping. So just imagine you have created different anchors in your home, right? And you did not go from one space to the other space. So specs cannot know the relative pose between these two things. So what we can do in the system is we can load several maps into our system. And while you explore the area, we also map always in the background. We can just hang on these maps and then we can just fuse them together. And this is a very powerful feature because that also allows it to fuse different anchors and they will be then in a larger map. And now as you can see here, so what we did here is we fused these two yellow maps together. They are now combined or they are now part of a larger map. And what we will do is we are just going to save out the entire map. So now from that moment on, when you connected these two maps one time, we can now save this out. And even if you start over here, you will see that your spatial anchors are popping up everywhere in your room. And this is a feature that we just added under the hood for doing that. What it's also going to do is, while you're using your spatial anchors, it will under the hood maintain the map that has been created before. And with that, we just, by reusing it, it keeps it updated. So even if you change parts in your environment, you swap out your couch at one point, or you might swap out an image that we mapped before, it will just update that information because it still can snap onto the other stuff that has not changed, and it will be baked into the map. Also, what they said, like it's an algorithm that we really want to have that really needs light and also texture. So if you want to set up something for a customer, for instance, you want to have like, there are now AR experiences where you want to have something local or you want to have something persisted, you can help the algorithm a lot if you just make it nice for tracking, so and also make it reliable for tracking. And it's just a classic example. So on the left side, you have many corners and points we can hang on to. So what we really like are these intersections. To be honest, the circles are not so good. This was messed up by AI. But in the end, these corners are really good. Also, what we can hang on here is that. And also the lighting is very important. The lighting is important because our cameras will just increase exposure time once it's dark. And you can also see that on your normal smartphone. Like if you move it around very quickly and it's very dark, you will see a lot of blur. And this is also what our algorithm is going to see. If it's blurry, you don't detect the corners. If you don't detect the corners, we cannot really relocalize at one point. So if you can control the light, just turn it up as much as you can and as much as you would want to. And then also just make sure that there's something that the algorithm can track. What are other challenges that we see or that people usually report? So here on the left side, you can see a park, right? And here I just depicted what the algorithm is going to pick up. So all these points here, they're good for VAO, so the text-of tracking system will work. But you can imagine if you come back the next day, it's very unlikely that you pick up the same points and we can find matches between those things. Also here, the tree line, that might work, but it's also far away. But basically here, also this is a repetitive structure, which is also not very nice because it's not very distinguishable. Also, where we would struggle is seasons, not an issue in California, I guess, right? Winter and summer, it's also very hard for us to detect the same things. And also viewpoint changes can be a challenge. It can be robust towards scale change, so distances, but different angles. It can start struggling here. So if you create a map for something like a custom location, you just want to make sure that you have all viewpoints covered. And the lens that we created for creating a custom location will also guide you during this process. Now, what are the mapping-enabled features that we are shipping right now in Spectacles? So first of all, we have the custom locations that I mentioned already. Those can also be used for location-based experiences and also connected experiences. Connected lenses use two different algorithms. Usually, you connect using iConnect, which was shipped, I think, in October, if I'm correct. And iConnect is one way that we can bootstrap the entire mapping and relocalization process in the background. So if you use connected lenses, you usually only have to look at each other these days, and it will connect. But in the background, what's going to happen is we are creating a map, and then we're sharing it to all the devices which are in there. And then if people just join them, you might not even need to look at each other, and it would just connect you using the map that we have. The map in the background is also used for corrections here. The next thing that we have and that we wrapped around this very same mapping algorithm we use for everything is persistent content. So you can place spatial anchors. So it's a TypeScript module that you have in Lens Studio. It will create the map, it will serialize it out for you, and it will make sure that if you come back, you will see your sticky notes popping up again. And another thing that is happening under the hood and that people usually might not even notice ideally is drift correction. So whenever you use mapping or you have a mapping session in your lens, we will, under the hood, correct the drift of the VAO system using exactly these loop closing capabilities, making it more correct. There are use cases where you want to be very, very accurate, and here this can be super useful. So let's go maybe to the custom location use case first. If you want to have a custom location, so you want to scan something in, you want to edit content against this location in Lens Studio, you just need to use our custom location creator lens. So you can get that, you can see it here on the side, how it looks actually, and it will then guide you a bit through this mapping process. So what it's going to do is, it's creating a mesh and creates under the hood the sparse map. It allows you then also to verify that verify that the map is good, and you can also test it using the very same lens. And once you click upload, it's going to be uploaded into our cloud, and you get an ID. This ID can be used on a located add component in Lens Studio. And what it is going to do is it's going to pull down that mesh that we just uploaded and created. It's a colored mesh. And then you can start editing your content against it. So we don't expose the map that we created under the hood. I mean, you have seen there are just many, many points. And it's very hard for a user to recognize which parts of the room that were. So this is why the mesh is much, much better. But this is only used for helping people to create lenses. It's not really a high requirement for our system that we have this mesh. So this is not used for persistent content. And once you created that map, that lens, you can deploy it to the user. And the lens itself will then download all the information it needs for localization. And it will then just show the content in the right place where you are. This was the very same thing that we used also for the dome experience, where we had many people running around. How to get most out of it? So as I mentioned already, if you really need to have a very accurate experience and you really want to be on point, you want to be kind to your SLAMs, so the VAO and mapping system. What does that mean? Take care that there is enough light. Also, don't do crazy motions. Like, don't run around and shake your head as crazy in the end. So if you just walk around and just don't run while you're creating that lens, that's already very good. What you can also do is you can even treat the system better if you want, and this is for making sure that there are loop closures. And how that works is, in the end, I'm looking now at that slide from that perspective, right? And now if I'm just going over there and I'm mapping everything, I can just turn around and make sure that the algorithm sees the same thing over and over again, and then it can correct it, right? And this is also what we usually take care of. So we look at the same thing from different perspectives, and then you usually have no issue relocalizing very nicely. Also, if you can, just keep the locations that you have as small as possible. So the larger the map is, first of all, you will need to download much, much more information, so it's slower during startup times. And it can also be that you introduce inconsistencies if you don't loop close over and over again, if this is not happening. So these inconsistencies are not very harmful in the end. What is just going to happen is that the user will see corrections in this map over and over again. So it's not going to break, but in the end, it might be a not so nice experience if you see these corrections over and over again. Something else that we introduced, which can be also super useful, are custom location groups. With custom location groups, which are also supported by the scanning lens, you can, for instance, in a museum environment, you might want to have different rooms mapped out. So you can just go to one room, create the map, and then you say, I add that to a custom location group finish that custom location, then you just move on to the next one. What we are doing under the hood is that we have isolated things, so they're quicker in loading, and we connect them using our tracking system. So once we are able to snap to one of these locations, all the others will also be tracked automatically because they have been connected during creating these custom locations. Custom locations are not, like I would need to look it up, but I think you can have something like 64 custom locations in the custom location group. The only thing you have to define is 5 different entry points into a custom location. So you'll be able to say, okay, I usually think people will start in this entry room, so this should be an entry point or also somewhere else. So up to 5 custom locations, they will be just prefetched and download. We will try to snap onto them, and then in the background, we will just load the additional information that we need. The other thing that we have is connected lenses. So if you have not had the chance to have a connected experience with some of your friends, I mean, it can be hard to have 2 devices in the same spot, I think. I would definitely recommend to try that out. It's really a nice experience. Finger paint is the classic one. It's a very easy to use lens. It just gives it to, adds it to a new level because you're not isolated anymore in your AR experience. You can share it with a second person, and it makes it very, very immersive. It feels like having it in the real world, the entire thing. As I mentioned already, what we use is eye connect. So what we are going to tell the people if they start a connected lens, we just tell them look at each other, and that's usually already sufficient. That's also pretty nice if you are around a table and people want to play a game. They can just look at each other, then we will connect, and then everyone is just in the same coordinate space. However, if you are already in a game or whatsoever and another user joins, so a 4th or 5th user, it can be more convenient that they just use the map that we have created in the background. And they will be still prompted that they need to look at somebody, but it can also happen that if you just look around a little bit, the map that we shared in the background is going to snap, and then the content is already there, and it looks extremely seamless to the user because they did not have to do anything for it. What the map is also doing in the background in connected lenses, it's correcting it. Like it's correcting the drift of the VAO system. If you run around a lot, then you can add up inaccuracies. This is especially the case if you locate it at a point that is very far away and you have a very long lever arm to that. So usually each and every relocalizations and connections, they are not perfect. So we have small orientation errors, small translation errors, and especially the orientational errors that we have, they are just they're just amplified by a lever arm that you have. So it's like a very small change here. So if I change here by 1 degree, it might just be a larger change over there in translation. And what the mapping algorithm can do is it's just going to correct that and fuses everything together in the background to make sure that, that the experience is still aligned even if you're further away. However, also here, so if you want to get a very accurate connected lens, what you can actually do is you can keep it local. That means you just try to connect in an environment. You stay there where you where you started the lens, and you don't start the lens over here, and then you just run away 100 meters, and you start the experience over there. Also very powerful here is that you can combine connected lens with custom locations. That means you can create a custom location up front that will be used for aligning spaces, but then other users can just join that experience, and you can then experience something together. So you can have a game that you're playing together in a certain room that you mapped before, or you can do something like the connected console experience that we were also setting up for the dome, and then people will just experience it together. The last thing that I want to mention here is spatial anchors. So this is just something that wraps around the mapping algorithm in the background, and it takes over for the lens dev and also for the user all the serialization that needs to happen. Usually we want to avoid that actual end users need to do a certain dance that the map is created. So we want to hide it away from them, that they can just start using it. And this is also what spatial anchoring is doing. So there is no prompt and no tutorial for a user how you need to map your space and how your motion has to look, that everything works nicely. You just create an anchor. We will take care of all the rest. It creates a map in the background. We align it. It will serialize it for you as well. And a user can, by that, use persistent contents. That's actually the same use case that Mitchell just mentioned. So you can just have your desk, you create a spatial anchor, and once you're coming back, it will just snap onto that, and things are still there where you place that. Or maybe even a weather forecast that you want to have in your, always in your living room at the very same point. You can also use a spatial anchor for that. And you don't need Lens Studio for editing something, right? So for custom locations, you need to load in that mesh, and then you need to create a dedicated lens for it, and then you need to deploy it. For spatial anchors, a user can do that by themselves without even needing to change the lens. Also here, the underlying map grows and improves over time. So this is what I showed you before. So you have this incremental mapping and also the map fusing. That also means we can keep it updated under the hood. And it's still there, even if you come back maybe a few days later. Something that we have updated in October. So if you have tried it out before October, there were some fixes that we just were shipping on October 2025. Before that, it was needed that you tell the anchor system in which room you are, and we were just able to extend individual anchors. We improved that. So now what you can do is you just need to tell the user, for instance, that you're in home, that we can just limit the amount of anchors that we would want to track. And then it's going to fuse all these anchors together that you have created before. And what this is using is exactly what I showed you before. So in the end, it's going to load all the anchors that we have for a certain area into the system, even if they were not connected. And then we will just connect them on the fly. And that gives you then also the opportunity that you can relocalize then better to your anchors, and even from positions that you have not seen in the very beginning. They were just connecting over time. Another thing that we are shipping is drift correction, which is just a side product of creating a map on the fly. So I just created here a small video in our Vienna office. So you could see here I was painting around the corner and then just running in a circle to make sure we make things drift. So if you come back, you will see that it's just slightly offset. And this is the pure VO drift that we have. Like I also tried to make the system drift by being not very nice and kind to it. If drift correction is turned on, and you have a very similar trajectory, or you run around, you can see that it's still there where you have painted it before, and it's on point. Drift correction itself is not on by default, so we don't run it all the time, but we run it as soon as you request mapping in the background because it's a side product. This is mainly due to power optimizations, although the mapping algorithm itself is not super power hungry. As all our CV algorithms, the mapping algorithm runs on one of the two SoCs that we have in the device. So also the thermal budget that we have is usually not maxed out by our CV algorithms, which is usually a little bit higher, or where we have less budget because lenses are usually heavy, is on the app SoC side, where the system is just heating up due to renderings. By running the CV algorithm on the CV SoC side, we can just distribute the thermal heat a little bit, and by that it's super safe to run, for instance, mapping, and you will see, of course, slightly reduced battery times, but there are no tragic impacts on your thermal capabilities of the device. So how to get most out of your drift correction? You just need to add a mapping session to your lens. You can just do that under the hood, and then it will correct it. And also, power usage of our mapping algorithm is fully adapted to the motion that you have. So if you have a leaned back experience where you don't move a lot, we will also not run the corrections all the time, because we are just seeing all the time something that we have seen already before. We detect that, and then we are not going to correct. So once you move somewhere else where we detect that this is now a new space and we might get more additional information for corrections, we will spin up that entire thing, it will correct, and then it goes into hibernation again. And by that, we can also guarantee that the power usage and the power overhead of drift correction is actually quite low. Now to the last part that I just want to show, it's meshing. Meshing is really great to play around with. Like I personally also like just to go around and mesh stuff. So this is, it just looks very nice because you can see that the device is detecting your environment and it's then creating just a mesh. It's not super costly on the CV side to create that mesh. However, it can be super costly to just render all of these triangles. So visualization can be the bottleneck. However, you can kind of fix that a bit. Or you can be more power efficient if it comes to these renderings. So what you can see here is kind of a mini map of the environment that is here mapped. So which is super nice, but also super inefficient. Like you have many triangles here. Also, I think we use normals here to color the mesh, and this can be super expensive. If you use something like the grid in the background that you can see here on the larger one, this tends to be more power efficient. And also, since we only see a part of the mesh, which is overlaid, we have less triangles, less things to render. And it's still a pretty cool experience. Something else you can use, so maybe there are also use cases where you don't need the full mesh, where you can just use some of the other things that we're providing. For instance, if you want to detect the ground. So there's something that we call semantic heat test. So you can just have a ray on your hand or on your wrist. You point on something on the ground, and then you can, and then the algorithm will just tell you here if it's ground, if it's not ground. This can be super useful for placing some content and doing also some kind of detection if there are objects or not. Another thing that you can use with the mesh is physics. And for physics, you don't need to render the mesh. So you can just use it under the hood. This means there is not no overhead on the aperture sensor, way less if you would have to render it. And you can still do cool stuff with it. So it lets your device detect if there are objects, and then the objects can interact with the virtual objects that you have. Multiplane detection, which is a super cheap alternative to meshing. So what you can do here, it's just going to spin up different planes, and this can, for instance, also be sufficient for certain use cases that you have. You only need to detect a wall, but you don't need a high-resolution mesh of your environment. So that's basically it from my side. So I don't want to stand between you and the lunch anymore. If you have any questions, just feel free to ask.